myself. I'm Terry Story, Stories in the Dirt. And today we are recording natural beekeeping conversations, and we're talking about queen bees. So again, because I wasn't recording a moment ago, I will just reiterate, if I will try and pay attention to people as they come in, and then on the chat window, if you hear sound quality issues or video quality issues, please shoot me a chat and I will see what I can do to fix that. Okay, so there we go. Let's talk about queens. And as I usually do, I will, let's see, there we go. Hopefully that was enough. I like to always share this bit of information from the Livestock Conservancy, a book that I have from them on breeding animal husbandry, in which they say, this book explains strategies that help ensure survival for breeds of livestock and dogs. Success in maintaining breeds is difficult to measure, while failure is easy to recognize by failing numbers of animals within a breed or by outright breed extinction. Lasting success for breed management involves much more than breed numbers and is based on a firm grasp of the biological aspects of the breeds. And I always want to bring this up because I think sometimes we forget that we are actually, what's the word I'm thinking of? Stewards. We are stewards of not just the land, but the animals as well. Not everybody considers bees to be livestock, but when you're working a farm or a homestead, that is what they are. And there's nothing wrong with that. If you're using them as a hobby for your garden, then they may just be, an additional kind of a pet. But truly, we should be working in conjunction with the animals and observing them and making the best decisions for their outright. Production, I guess, not just production in the means of producing honey, but producing a healthy bee. Right? And as the Brits say, we have a duty of care. We're gonna have a little lag time on this screen here. There it is. Duty of care. I love the way that the Brits say that, and I hope we all think of our responsibilities as stewards as a duty of care. And I will drive the idea home just a little bit with my own philosophy. This is something I developed as a mother. It is the metric in which I decide what to do for my family, what to do for myself, my own well-being, how to teach my children. And I've taken this concept and tried to apply it to my homestead and my farm. And that is happy, healthy, safe, and strong. Are the decisions that I'm making, are the things that I'm implementing, are the choices that I'm making going to produce happiness, health, safety, and strength? And that can be applied to just about every aspect of life. So that is something that I do. So when we think about the happiness and health, safety, and strength of a bee, we want to understand our responsibilities to the bee, which is that metric for making decisions. We want to understand the nature of the bee, have respect for that nature of the bee, and get out of the way of nature, to be quite honest with you. Let's see. So in addition to them being livestock, they are producing for us, but we don't want to take so much from them that we are impeding their ability to be successful in a healthy and natural way. So we want to share in the bounty as opposed to working our bees to death for our benefits. And something that is probably a philosophical debate between people or amongst yourselves or with yourself is that honeybee colony losses do not equate to poor bee management. Naturally, bees die. Colonies don't survive. I think the natural swarming hives have like a 20 to 30% success rate. So if we have an abundance of bees and we have a die-off rate of 70% of new swarms, those bees that survive are stronger and healthier. That doesn't mean that we didn't have success raising our bees. It means that the ones that were not sure, were not capable or have the skill set or the natural tendencies to survive just didn't survive, and that's okay. So I as Charles Darwin, of course, he has a wonderful saying that has been bastardized to some degree and abused in a lot of ways, but I think that it's applicable to what we're doing with the bees, what I'm doing with the bees anyways. And that is, if it is not the strongest of the species that survives, nor the most intelligent, but the one most adaptable to change. And I think that applies to all of us in a lot of ways. So on that note, let's see if we can find a queen bee. Yeah. There she is. And when you see her, you will know her. She is a much different shape here than the rest of our bees. You see all the different kind of bees that are working in here. This is a new hive. It's got a little bit of brood starting up over here, and some nice empty cells that had an old frame to start this colony off with, so that was really nice to see. And so let's talk a little bit about the bee itself and how the queen is designed just a little bit different than a worker bee or a drone bee. So first of all, we know that her abdomen is much longer, right? She's got to carry all that, all the sperm and all the eggs, right? She's got to store all of it for her lifetime of production. Because she is not a forager, she does not contribute to the collection of pollen or honey. She does not have pollen baskets or brushes, right? And she's not out gathering, so she does not have a long, oh, I can't remember the group name of their mandible space here. Not the mandibles, but the maxilla, labial pulp, and glossa and proboscis. Yes, I am definitely failing in that department. Anywho, so she's going to have a shorter mouth functions here. And then I guess I missed a couple of my arrows, but I'll go in a little bit more in depth in this. But she also is lacking some internal components. So here are a little bit closer up, and we can see that, again, the longer abdomen, she's lacking the brushes, lacking the pollen brushes in the baskets, right? And that is because she is designed for egg production, right? So half the size of the mouth parts is a worker bee, and her mandibles are notched. And I'm not quite sure what the purpose of that is. It may have something to do with moving the eggs around, but that probably is just nonsense I just made up. Okay. So let's get interior with her. As we can see here, she does not have the, got some extra stuff here. She does not have the glands for making royal jelly, wax glands. She does not have the, let's see, I think this is the wax glands. Oh, and her stinger. Her stinger is shaped differently. It is more curved, does not have barbs, and is longer. Typically, a queen will not sting a person, so you can hold her in your hands without too much trouble because her stinger is reserved for, eliminating competing queen bees. So when they come out, that stinger is designed to puncture the additional queen cells to limit her competition. Okay, so the queen or mother, right? She's the one who produces all the eggs. Can lay between 0 and 4,000 eggs in a 24-hour period. Peak production is going to be in the spring, right before she's going to start laying, just before the spring honey flow starts, and will produce higher egg populations, if you have, say as an example, you have an intermittent growing season. A lot of folks have what they call the what do they call that? The drought kind of. It's not a drought. It's the dearth. So if you have a dearth, you're likely to see a drop in production of eggs because she's not going to need or have the capacity to maintain a brood. The colony will not be able to facilitate the growth of the brood in that downturn. So you'll see a reduction in brood. But if you have a second bloom, a second honey flow, she should be rearing another series of brood. Of course, it will not be nearly as big as that early spring brood population. So let's see. As you can see here, most queens are productive in their first 2 years. Egg production is also affected by genetics and environmental effects. So as an example, spring honey flow, right? Or a drought, a literal drought can affect the foraging, the forage that's available. So she may cut back on her production for that. If there's not enough space inside if they're starting to fill up, right? There's plenty of honey, plenty of brood, and there's less space for her to lay new eggs. This will stimulate, that's that other aspect of the colony that I was just discussing. So they will have a group consensus and the queen, and they will start to make swarming cells, right? And those queen cells in preparation for moving out. So they will leave a portion of the hive behind and set it up for the next generation of bees. So, and then of course, the availability of honey and the time of year will affect egg production. So, okay, brood cells. Brood cells are tilted up to prevent honey from running out. Appear to be a 6-sided prism of wax. Worker cells and drone cells are different sizes. And if you look at your pattern inside where she's laying her brood, about 9 to 10% of your cells will be larger, and that's where the brood is going. The drone cells are going to be. I'm sure you're aware that the drone broods are all males, which is directly related to, the queen's maiden flight and that production of the next colony. And let's see. Oh yes, between the worker cells and the drone cells, you will see a kind of a change, kind of like a not quite 6-sided hexagon, or not hexagon, obviously. I'll have to double check that term. But the cells will be just a little bit wonky to facilitate the size change from the worker cell to the drone cell. So you can look out for that when you're trying to identify which cells are which, if you can't tell the difference in the size itself. So here is a lovely, I'm calling this a frame map. I got this off of the usfard.org page in their Honeybee Biology Basics. And you can see in here. So this drone brood, you see how it's got a larger cap on it. These worker bees are not, see, there's just a little more flush, right? Honey's going to be kind of recessed. Pollen will have an open cell right here, right? And this is an empty cell where a little pupae has evacuated. Full-grown little worker bee has moved out of there. So I don't think we saw any. Go back. I don't think I saw any queen cells on here. No. So the queen cell is often described as a peanut in appearance. It will come off of the bottom of the frame, right? So let's see if we can make this work right. Yeah, kind of like this, right? It'll come off of the frame, be sticking down and out just a little bit. Excuse me. And oh, excuse me. Yeah, and have the kind of the shape and form of peanut. The difference though, if you find that you're seeing those little cells coming out of the middle of your hive, those are emergency queen cells. Your queen may have been hurt, she may be dying, she may be gone. This is not something that they do normally. I imagine that those cells are forming in the middle because they didn't intend to make it, and so they're quickly switching over a worker bee to become a queen bee. Right. So it takes about 15 days to 15 and a half, so 16 days before a queen hatches. Something to bear in mind when you're raising queens, or if you're hivelet or you're queenless in a hive, how long it's going to take before you've got more brood production. And if you're having swarms, that's something to consider. There will be a gap anywhere from 10 to 20 days if the bees haven't started a queen. So they may have a few days of lag time, right, before they start that next one. So anywho, after she is hatched, she takes about a week just to kind of, probably feel her way around and get used to everything, understand how her wings move, etc., like a little child learning how to walk. So after a week, she'll take her orientation flight, and she may take several practice flights very close to the hive. And then when she's fully ready, she will take a one and only solo flight, all by her lonesome. No guards, no protection, no nothing. This is obviously the most dangerous time in her life. So wish her luck, I guess. Anywho, so she will fly out and to a place that's called a comet. Comet apparently is a place where males tend to congregate. In fact, that's, I think, where the word comes from. We'll talk a little bit more about drones in just a minute, but her flight might be as little as a half a mile to 2 miles. There were some studies by some gentlemen in Austria. They've been studying these, and we'll talk more about them in a minute, but they had found that queens would fly as far as 10 miles to find a drone comet congregation area. So typically, as I understand it, swarms will not occur without, not as I understand it, swarms will not leave without a queen, that's for sure. When they fly, once they've decided where to go, the worker queen or workers will protect her in flight. So they'll take off, she'll take off, and they will hover around her like a little shield of bodyguards, right? And they will fly with her and set the pace and the momentum, and then she will stay with them. If they lose her for some reason, say there's a windstorm or a tree comes out and smacks them, birds or whatever the obstacle might be, they will look for her, try to gather her up, and then carry her along with them. Should they lose their queen, they will return to the original hive. They will be stressed. They will possibly be confused. You'll see them flying around, probably frantically trying to find her. And of course, there will be a new queen in less than 10 to 20 days. So if it's an emergency, like evacuation, swarming situation, it's obviously going to be longer before you get a new queen. But if things are, pretty standard, you might have a queen in as little as 10 days. So synchronicity. So because I was talking about earlier the pheromones, queens, and I'm not 100% sure on how the pheromones work with whatnot, but I do know that queens determine when brood production starts. They manage, if they don't have brood production, then the honey flow foragers do not go out, right? So if you have a queen bee, so as an example, say you're in New York State, right? Probably a zone 6, maybe 5 in some parts. Honey flow is probably not going to start there until, I don't know, maybe early May in some parts, late April in some parts, but definitely will be in full production by late May or early June. If you take that queen and she's in, say, zone 7 or 8, she's not going to start brood production until what, mid-April, late March. So by the time the honey flow starts here, or by the time her brood is ready to forage, our honey flow will be, where I am in zone 7, will be largely used up. It'll be done, right? We'll be coming to the waning right around June, 2nd week, 3rd week of June. Things start to cut back and we have our dearth. So sometimes beginning to mid-June through to August. So those bees will have nothing to forage and they'll be starving right off the get-go. On the flip side of that, say I'm here in zone 7, I take my bees to zone, 4, 5 or 4 or 6 even, and they start brood production and they're ready, say, that 3rd week of February, 1st, 2nd week of March to go out and start foraging. Well, they're going to freeze, they're going to die because those bees are not, that queen is not acclimated. She's not in sync with the local fauna, right? On the other flip side of that, say it's coming into the fall, right? And my queen has a second honey flow down here, and I've taken her up to the north where things are starting to shut down. You can have early snowfall in some of those places as early as, September, and she's still trying to produce brood for that second honey flow. Well, then she's got a population that she can't feed, and that hive is going to fail. So understanding the synchronicity of your queen and the synchronicity of your local fauna is extremely important when raising your queens and determining what queens to raise. And then, of course, polyandry. I'm sure some people have a negative connotation with this term, but if you're looking at it from a bee's perspective, it is one of their factors for maintaining genetic diversity. So if a queen is limited in her gene pool when she goes out to mate with the drones, she may not have as strong of a colony because the diversity contributes to the varying degrees of the bee's ability to do a waggle dance, or bee's ability to go forage, or to maintain brood temperature, or even to handle disease and pests and things of that nature. So it's extremely important to take that into consideration when if you're doing a breeding program, or if you're getting bees from somebody. You want to understand how the bees are working so that you can understand when you talk to a bee supplier, queen bee supplier, what kind of bee genetics are you actually getting? So, on that note, you can't have queens without drones, right? It takes 2 to tango. Interestingly, drones are what they call haploids. The technical, or the Latin meaning, I guess, is virgin birth, and that is because queens, when they're drones are, how do I say this right? Unfertilized, right? So they have half the chromosomes of the queen, okay? Which is another reason why they have to have, not one of the but probably another one of the reasons why diversity in the polyandry aspect of a bee is so important. Okay. So drones take the longest to develop, 24 days in total. If you're in an area where varroa mites are an issue, this is one of the reasons why this practice of killing drones came into play, right? Also, they don't contribute to rearing the bees. They don't, other than genetic diversity, they don't appear or didn't appear to contribute much more to the colony. So some beekeepers treat them as an annoyance, basically, and we'll call them, right? They take up honey space and basically are looked at as a nuisance. So peak drone production occurs several weeks prior to swarming season, right? So you're going to look at your honey flow, right? Honey flow is going to start filling up the hive. Her brood production is going to be filling up the hive, and that includes drone production, right? It's twofold. One, when she swarms, the virgin queens need to take a mating flight, right? And if there aren't enough drones in the area, then she's not going to get enough genetic diversity or be mated fully, which is unlikely, just because of the amount of sperm that a bee can create. Even one should be sufficient, technically. But there's no coincidence there. It's on purpose. So if you're going to have swarming, you're going to have a need for drones, and queens will be shortly thereafter. So, and in just the same way that a queen is designed for a single purpose, that is egg production, the drone is designed for mating, right? So they also do not have pollen baskets and no stingers at all, right? And other equipment that is required for workers. After the mating season or in times of stress, the first bees in the hive to be culled are the drones. They do not contribute enough to spend resources on, and after mating season, they really have no purpose. So they will often be moved out or culled. Also, because they, do contribute to the genetics of a hive, it makes sense that all drones are accepted into all hives, no matter what. Okay. And a healthy hive should have approximately 8 to 10% of drone population. So they're not deadbeat dads. They actually can contribute to the maintenance of the temperature within the hive, which allows foraging bees to go out earlier or to be able to leave the hive at all, so that they're not spending their time maintaining the temperature and the ventilation of the hive. Okay. Comments. Years ago, I think it was 2013, I was such a nerd. I had all my little bee books and I was reading, and I had my little highlighter and making my little notes. And then life happened and I got busy, and then I picked it up again and I was reading, making my notes and my highlighter and everything. And recently I found a box of books that I hadn't been into for a while. And in it were my old honeybee books. So I pulled it out, and it's so interesting. If you don't use it, you'll lose it. So a lot of the things that I'm actually like relearning now, I see all my little notes where I had actually, read these things before and learn and kind of should have known about some of these things before. Well, so years went by, I didn't do anything with the bees. And finally I got to a place where I could have bees. So I joined a local bee club and started learning kind of all of this stuff again. And then now I have actual bees, and I can put my hands on the bees and I can touch the bees and I can, look at them and observe what they're doing. So a lot of the things that I had already forgotten, right, and I'm learning again, have so much more meaning now because I'm actually doing it. So that's one of the reasons why I wanted to start doing this conversation, is for those people who, are starting or have been down the road or thinking about it. You can't hear some of these things enough. Like, you forget about them, right? But after you've done it for a while, then it's just second nature. So I remember I actually found my note on comments, and just found it interesting that I had zero recollection of it until I recently listened to another book by, let's see, Thomas Seeley, The Lives of Bees, and he talks about them in that. Anywho, orientation flights for our little drones are at day 6, lasting several minutes, and they are steadily getting further and further out, and by day 12, drones will start to congregate in small units called comets, right? Scientific or Austrian researchers have been studying comets since the 1860s. And upon, first I listened to Mr. Seeley's book, and then I read Mr. Seeley's books. So reading it again, I came across and was really looking at how the drone bees find their comet area, because apparently they use them again and again and again. They've been studying some of them for decades now. So it's not a fluke as to where they're showing up or how they're getting to where they're getting. It appears that they're narrowing in on, like I can imagine being a little bee flying around, and when you're mating as a little drone bee, you're flying really fast, considering how tiny your little body is, right? And so you probably want to have as much light and as little obstacle as possible. Space doesn't have to be massive, but it has to be, safe, I would imagine. So they're finding that there must be some mechanism in there where they can observe very well lit areas, and even if it's tucked down, kind of like in a little crevice, if it's like a little meadow or something, and there's a lot of light, full light, or at least plays a big part in that congregation area. And they can be on average 1 to 4 miles from the hive. But again, in one of their studies, they apparently had found one or some that traveled as far as 17 miles to their congregation area. One of them may have flown, instead of up and over, around like a small hill or mountain. So like 3 miles. Anywho, do not quote me on those numbers. Go grab Mr. Seeley's book and check it for yourself. It's an excellent read. Okay, so sealing the deal. Okay, as a drone, it's the real deal. The impact from the flight, in addition to the act itself, they leave their reproductive organs in the mating process. They're done. Lights out, game over. So, yeah, that's it. So I wanted to talk about a little bit today about the basics of the queen bee, introduction to drones, and a little bit about their mating process. We can talk much more about some other stuff as we go along in these conversations, but I thought it best that we just start off with the basics and see what goes from there. And I always want to leave this in your mind as we're wrapping things up. Are we raising strong bees or strong varroa mites, pests, and diseases? I think our practices in the apiary should be cognizant of what we're actually intending to do and what are the consequences of our actions. So just because we want to protect the bees from disease and pests, are we actually doing that? Are we interfering in their ability to develop a strong defense naturally? That coevolution is the most powerful tool that they have. So interfering in that particular practice is, from what I'm seeing, potentially endangering the species as a whole. So just like antibiotics are with, MRSA, are we creating a stronger pest, disease, bacteria, virus, or are we creating a better, stronger person or bee? Right. Okay. So all in all, how did we do? Oh, it's about 40 minutes, so not bad. I hope that you all enjoyed this conversation. I look forward to visiting with you on the next one. If you have any questions, shoot me an email or shoot me a message on Facebook. I am not real keen on the Facebook thing, so probably email is the best. All right. Have a lovely day. Happy beekeeping, and check out what we're doing. I'll repost this later on YouTube at Stories in the Dirt, and you can follow us on all the other social media items. And thanks, y'all. Have a good day.